Thanks very much. So firstly, let's get some introductions out of the way. I'll ask each of the panellists to briefly introduce yourselves, and then we'll get stuck into some questions.
Yes, thanks everyone. Adrian Constable here. I work for Caterpillar, one of the traditional suppliers to the mining industry. I'm now working in Caterpillar's renewable and energy storage division, which may be a bit of a surprise to some people, but looking after microgrids for Asia Pacific.
Hi everybody, I'm Daniel Thompson. I head up the development effort for Solar Reserve here in Australia. Solar Reserve, for the company, for people that don't know who we are, we offer a very unique product into the market insofar as we have a solar technology which is fully dispatchable, and we achieve that by storing energy in the form of molten salt. So we have an operating facility in Nevada, and we're looking to deploy that here in Australia, both on grid and for the mining space.
Hello everyone, my name's Matt Curry. I work for Aggreko in business development. We have about, roughly 10,000 megawatts of gas and diesel generation located around the world. We've got our first solar diesel project coming online in January of next year in Eritrea. So in Ivor's slide pack, he had a map of the world, and ours was the 7.5 meg station. So we will own and operate that station. I suppose a little bit about me. So I used to work for Energy Developments, and before that worked for Merrill Lynch and BP.
Good afternoon, I'm Jenny Purdy. I'm the CEO of Adani's Australia Renewables business. Renewables is a new line of the projects that Adani's doing here in Australia, but probably 12 to 18 months since the work on that started, and I joined in February of this year. In terms of what Adani's doing in Australia in this area, we're seeking to build a leading renewable energy business. We've got two projects at the moment that we're in the late stage of developing. One is a solar farm at Moranbah in Queensland, initially 65 megawatts, but potential to get up to about 200. And the other's at Whyalla, another solar farm there. But more in terms of how we might grow the business, we want to get to 1,500 megawatts in the next 5 years. And we need to do that by partnering with customers to provide energy solutions. So a lot of the discussion we heard yesterday about the need for producers to come to customers with a whole solution is something that we don't have the answers to, but we certainly agree that is the right question. In terms of Adani, people are probably aware of our project at Carmichael, which is a mine rail project, 25 million tonnes, and that's I guess another area where we're in the space where we're looking at what might be a solution to the energy needs for that plant, and more broadly in India, of course, Adani has about 1.2 gigawatts now of renewable energy, about 10 gigawatts of thermal energy, and a goal of growing the renewables to 10 gigawatts by 2022. We've got the world's largest single-site solar farm at Kamathi, and we've also got a 1.2 gigawatt per year solar panel manufacturing facility. So vertically integrated in that in the global context.
Thank you. My name's Linden Prius, and I'm the Managing Director of a company called Acustica, formerly known as Cat Projects to some of you. We're actually based in Alice Springs. We're a technical advisory firm, engineers and project managers. And our specialty, with a history that goes back over the last 35 years, is of working in remote and regional areas around Australia, and over the last 10 years around Asia Pacific and India. So I've done a lot of work on everything from village electrification in parts of Orissa and fairly dealing with Maoist insurgencies and understanding how that impacts on viability of projects, to also running 150 meg projects here in Australia and the different challenges that exist around the logistics of building and operating those sorts of plants.
Thank you. So I feel like the topic that we're covering here, adapting renewables to fit mining's business model, has been covered at various points throughout the last day and a half, but hopefully this discussion brings it together a little better. But I'll start with you, Jenny. As Adani are essentially on-grid, and we've been talking about off-grid really predominantly for the last day, how do you view the opportunities for renewable energy projects with mining as an on-grid entity?
Yeah, I think the distinction you make between on and off grid is certainly one that when I think about this, I make that as well. Look, I think there's a few opportunities that perhaps we haven't talked about. Firstly, to the extent that you've got a grid-connected mine, you've got an infrastructure connection there that could lend itself to a renewable generator being adjacent. Often you often have good resource, maybe good solar resource if it's inland in Australia. You may have cheap land that's available around it. So, you know, is it possible to build a renewable plant that not only meets the needs or some of the needs of the mine adjacent to it, but also feeds into the grid and meets other needs too. So I guess that's a bit of the Sun Metals story that we saw yesterday, but perhaps in a broader context. Another opportunity might be a rehab site. For example, there are, well, I guess not mines so much, but there's some sites in Queensland that we're aware of where there have been power stations adjacent to mines. Maybe that's an opportunity where the infrastructure and the connection could be done more easily and more cost effectively. We know about the Kidston project, which is using an old mine site and using some of the I guess the infrastructure that's been created there through the mining of that asset. Yeah, so I guess also if we've got a number of sites that are close to each other, maybe, I guess you might not have the situation, but if there's one grid connection, are you able to almost do a strata title approach where you build one plant and then a number of facilities benefit from the energy generated there? So I think there are a few opportunities that we're certainly thinking about in terms of what might be solutions.
And maybe Daniel, in terms of a baseload solution, which obviously Solar Reserve are focused on, you know, what do you see in terms of opportunities with miners with that baseload type generation?
Yeah, look, we do see it as a really strong opportunity, and that's the reason that Solar Reserve has got its office here in Perth. It's really for that mining connection. But even with our technology, which enables us to provide fully dispatchable power, it doesn't enable us to supply fully dispatchable power 365 days of the year, because you can get sustained cloud cover that impacts our ability to heat up our molten salt and consequently impacts our ability to generate electricity. So, you know, we've looked at this quite recently actually for a large industrial customer in the northwest of Western Australia, and the solar resource there is amongst the best in the world. So we can achieve a capacity factor from our technology of around 85% over the course of the year, which I think is quite remarkable. And that's, you know, in the warmer season when there's not as much cloud, that's 100% capacity factor. But obviously that does change throughout the year. The means for us to get that last 15% is to heat the molten salt up with something else. So in this particular case, we'd be looking at using gas boilers, for instance, to burn a little bit of gas to get that last 15%. So it does enable us to offer a true baseload, fully dispatchable solution over the course of a year. And we see some great opportunities, particularly in greenfield sort of mine developments, to do that where there's not already a sunk cost in the power infrastructure.
Where you get involved in that early design phase. Yeah.
Correct.
Okay. Matt and Adrian, obviously you're in a similar part of the industry. Do you see opportunities? Obviously in mining, there are great opportunities for what you provide, but are there opportunities that we haven't discussed yet in the last day or so that you'd like to talk about?
Yeah, I can sort of speak to that a little bit. So I think there's been a lot of discussion on solar PV, which is a very important part of the renewable mix going forward. But I think you have other technologies out there that aren't quite as mature, but we're starting to see them, take shape, such as organic Rankin cycle. And I know we have people from KPS over here, their use of turbo generators. So to use, some of the exhaust heat, the unused, sort of energy that's coming out the back of these reciprocating engines and turbines in ways to generate power to improve efficiency. So that's another side to this. Yeah.
Just to add to that, I mean, certainly there will be increasing efficiencies in the traditional baseload power generation, etc. But I guess in general, I think that the path that everyone is seeing is that there will be renewable energy, and it's about understanding what is your resource at the site, and really determining how do we make the most of that resource. And it's an interesting one here with turning that into a base load, because traditional PV is not a base load generator itself. So that's kind of the key, is just understanding, of course, the location and what is the complete resource that you have at site, and that's going to be a combination of both traditional power and renewable power for the foreseeable future, I think.
So bringing you in, Linden, how are renewables succeeding or failing to fit into the miners' current power systems?
Well, I think that one of the challenges is there's a fundamental cultural challenge that exists, I think, between the renewable energy developers generally and then how that interfaces within both mining as a particular example, but more broadly commercial opportunities. Much of the renewable energy industry, if you understand its history, has been coming from renewables is good because it's good for the environment and there's all these additional benefits to you and you should value those. The significant cultural change that we're moving into is driven by two things. One is, I think, commercial consumers, be they large industrial or miners, are starting to value starting to value carbon risk generally, and that is influencing some of their long-term planning. But more significantly, we're moving to an environment where renewables are by themselves lower cost, but they still have some very unique characteristics around. You spend a lot of money to build the thing, but once you've built it, you've got a fair amount of energy for a long period of time. And so it means that your engagement around the value of the proposition is needing to change. And I think the big transition that we need to go through as an industry is moving from a lowest cost model, which is when we're seeing, for those who monitor Renew Economy or any of those journals, you see sort of almost weekly articles coming out with a lower PPA price. But the lower PPA price isn't actually transitioning to more stable generation. And so the next transition for the industry will be value generation. How do you sell a kilowatt hour that is the kilowatt hour you need with the characteristics around rate of change and frequency control and all the rest of it that matches the objectives of the mine or their commercial customer? So there's a transition going on in that. I think part of the challenge is that the description or the definition of grid and off-grid and fringe of grid is merging. It's no longer sort of purely geographically defined. The characteristics of the power systems are merging across the two. And it means that you start to then get a more mature understanding of what are the opportunities around the resource. And I think certainly the work we're doing is starting to look at, well, instead of just pursuing a lower cost, what happens when you start to change your AC-DC ratios on PV plants so that you actually have synthetic inertia by virtue of the fact that if PV is really cheap, which it is progressively getting cheaper, can you design a system that is not necessarily the most technically elegant, but because of that actually brings great resilience? And I think so there's a change in culture that both the off-takers have to understand about the new price paradigm that's coming, but the developers have to understand around, instead of just pursuing lower cost, they've got to start thinking more innovatively around the quality of the generation they're producing.
Yeah, and picking up on that, I think that's where Adrian and Matt come in, is the quality of the energy that's produced, or the reliability of the energy that's produced at the right time. So, that's obviously an opportunity where the renewable hybrid is going to deliver more value to a miner.
Yeah, I think one point that I'd make around that is that, so you have within mining PPAs, or really a lot of them are tolling agreements, not PPAs, in that the fuel's provided, by the miner usually, but within those agreements, there are reliability, availability clauses that produce liquidated damages. And I think for a miner, it's difficult to pass through the true lost cost of production through to a power supplier. So what I'd say is that your quality of power now at a mine site is very important, to a miner. You can't have crushers unavailable, where your power trips, you may have to evacuate a mine, and it might take 4 or 12 hours to have the underground mine, start up again. So quality of power is very important. And the point that I'd make around PV is that while batteries are yet to become economically viable, as we all know that they will in the not too distant future, but they're not quite there at the moment. The problem that generators face is the better engines to use to provide to provide power where you get cloud cover coming across a PV installation are your injected diesel engines, or high-speed, injected diesel engines, not your medium-speed diesel engines. But even those engines take time to provide the power that's required. So you have to be very careful around the amount of penetration or solar penetration that you put in at a mine site. So for us, there's a lot of work at Eritrea working out what's appropriate between the amount of capacity and the load and the solar PV that we can provide, and also provide the availability guarantees that the miner has within that PPA contract. So yeah, I sometimes go and talk to our engineering group, and I'll sort of maybe double the penetration and just watch their faces, and they sort of recoil a little bit, that sort of thing. But yeah, there's work to be done around that. But the sooner batteries become economic, the sooner that problem goes away in some way, shape or form. Yep.
Yeah, I guess so from Caterpillar perspective, and we've talked about this, it's commercial and technical. They're the two key things we need to get through everyone's mind to make them comfortable with. The commercial part of it, I think, you can do the numbers and we can work that out and go, okay, this makes sense, and it's very easy to do the detailed numbers on a spreadsheet and convince everyone that's our lowest cost of energy, whatever the configuration is, let's go down that path. I think the biggest thing is that everyone's, hit the nail on the head, is this reliability factor, so the technical. Now we're adding, multiple forms of generation that now need to coexist together and provide that reliability. Those actual technical challenges have been resolved, but I think they just probably haven't maybe necessarily been demonstrated yet in the Australian mining industry. And so we've just got to get through that portion of it, I think. The commercial, I think, is there. It's just demonstrating the reliability part of it, which is demonstrated in other industries and other parts of the world. But I guess we just need to demonstrate that in the Australian industry.
Okay. So over to you, Daniel, on the next one. How do you see the market adapting its offering to meet the requirements of miners? Because obviously you're a base load. Most of the renewables are intermittent. Obviously, you're coming from a totally different angle.
Yeah. Look, and that's a big challenge in the market at the moment. The mining sector is a huge opportunity for renewables to take a much more profound role, but we haven't been successful to date. You look at globally what renewables are on mines, and it's a kind of a very small number, and that's because those two things haven't aligned. What a renewable developer or a renewable kind of asset needs versus what the mine needs. So there does need to be that adaptation, and we've been thinking about this in a number of different approaches. Clearly, there is a big difference between being a mine that's on a grid versus a mine that's off a grid, and they've got very different kind of issues that surround it. But if I think about the on-grid ones, they're probably a little bit easier. If we're building an asset to supply a mine, the mine's probably still only going to have a finite life, which is less than the life of the renewable facility. But there is some scope at the end of that mine life, or the end of that agreement, to do something with that power, because the grid is there. Potentially, it could be another customer that could buy it at that point. Off-grid is a kind of a whole different kettle of fish. If the mine shuts down after 10 years and you've got an asset that lasts for 20 or 30 years, then clearly that's a fundamental issue. So we've been looking at it in terms of, is there scope to locate a facility where you can connect a number of different mines? Now, maybe that means that you've got to run some transmission, but if you're building a facility like ours, which are 100 megawatts plus, then potentially that cost can be kind of built into that project. Can we provide a product which is much more aligned to what the long-term needs of a customer? If there is a customer, and these do happen from time to time, where they have a long mine life, can we design an asset where they don't need another form of power? So it's all kind of embedded within the one facility. So I absolutely agree that that there needs to be an adaptation, and that's the reason that we haven't seen a greater uptake of renewables in the resource sector to date, is that those two have been misaligned and clearly it's incumbent on kind of probably both parties, but as a renewable developer, we're very aware that offering does need to evolve.
Linden, I'm interested in your view on this. You've got a lot of experience in remote communities, remote systems. How do you see that adaptation occurring? And you obviously you've been in the industry for a long time. How has it evolved to now?
Look, I think as I was alluding to before, the industry's been heavily focused around how can it drive costs down, and it assumed that the number of times I've seen presentations where someone said, well, diesel's at $1 a litre before excise, and that means that assuming average generation, that's about 22 to 25 cents a kilowatt hour. So as long as I can build my PV for 21 cents a kilowatt hour, job's done. And the reality is I think, as one of the presentations said yesterday, the hurdle's actually higher than that. There's got to be a greater premium or a greater price drop to accommodate the risk. And so the solar industry in particular, but the other industries as well, have met that by just driving the price down. I think the really big question that is still yet to be still emerging and is still yet to be really interrogated is, what does the world look like in 5 years' time? If you assume that the existing trajectories are correct, and all the data that we have says that for solar PV, every time someone's projected conservatively, it's dropped faster than anticipated. But what would the world look like if you were a large bulk mineral miner in the Pilbara, and you could have as much energy as you wanted for 4 cents a kilowatt hour, $40 a megawatt hour, but you could only have it for 12 hours a day? Now that at some respects, people would immediately go, well, we can't do that because we have to be a 24-hour operation. But 4 cents a kilowatt hour versus 14, 15 cents on gas, or 22, 25 cents on diesel is a big saving. So there's actually sort of almost a bit of blue sky thinking around going, this is fundamentally changing the way we think about energy. Our whole industry, not even just renewables, electricity industry has been premised for the last 10 years, the last 100 years on how do you consume less of it, because its cost always goes up. And we're now in a paradigm where the cost, oddly enough, and notwithstanding what's happening in South Australia as of tomorrow, oddly enough, the actual wholesale cost of generation out of renewables, when you start to project forward, is actually dropping faster than everyone predicted. And so it asks the question then, or begs the question as to what could you actually do with that? And at the moment, we still have very much our model is around supplementing or replacing an existing form of generation. The opportunity is actually in surplus generation, saying potentially if you go out, you might have a mine that's only got 50 megawatts. I could build a 150 megawatt plant there, and it might only, a 150 megawatt plant, I can probably build it with an offtake price of sub $100 a megawatt hour, maybe even sub $60 a megawatt hour. What could I do with all that additional engineering? What could I do with the opportunity that affords? And we haven't yet had those conversations, and it's quite transformational when you start thinking about that. In the context of places like the NT, we're having to have those conversations around long-term. We have access to the resource, we've got access to the experience around developing renewable projects. But the focus is all, are there jobs building PV plants? And we're having to transition people's minds going, what would happen if energy was no longer a barrier to the development of these areas? If we could solve that problem, what would you do? And that suddenly brings up things like, we could run more abattoirs, and that then changes our whole livestock industry, and all these other options emerge. And I think there's a conversation to emerge with mining industries around sort of that next generation of mining, and what level of mineral processing is done, how ore bodies are actually extracted, and what you do with those when you assume energy's at a far lower cost than current.
Yeah, and I think one of the points you made there about the overproduction over the top of your own needs behind the meter is what you were alluding to before, Jenny. In terms of overbuilding to your own requirements, what sort of thought has Adani put into that?
Sorry.
Yeah, look, I think the points that will be made here are a really interesting way to think, isn't it? Because I guess, my thinking, I come out of a manufacturing background. I spent 20 years or more working in aluminium, where there's not a lot of opportunity for the bulk of that load to be demand managed. There is some, but it's around the edges. And so my sort of mental model has been, we need to find a way to provide energy on a pull system. And then we need to firm the load, and how do we do that? So I think that's what we talked about yesterday, and I think that is one avenue to the solution. But I think the other one is what we just talked about now, and that becomes then a pretty much a classic CapEx OpEx discussion in terms of do you invest the CapEx and only run it during that part of the day when the OpEx is so much cheaper? How much cheaper does it have to get to before that becomes the optimal thing to do? And that, there's a whole lot of drivers in terms of the workforce and so on, whereby that might actually be a model that had some real intangible benefits for people as well as some tangible ones in terms of shift work costs. So as energy cost rises, and in terms of that firming cost, and conversely the cost of having it during a portion of the day becomes lower, that will push some different discussions. And I think if you then combine that with some of the things we're seeing in big data and ways to potentially help operators make decisions about how to manage their energy use in a much smarter way to take advantage of low cost versus avoid higher cost power, then you start to sort of potentially see a different way, and I think the truth will be somewhere in the middle. So in terms of what Adani is thinking about in that space, I think very much what solutions do we provide to customers, what do they think they need, but is there also some way to challenge those needs? How do we do that with a minimum amount of CapEx spend, and what OpEx saving justifies? Perhaps if you're having to put diesel plus wind plus solar plus battery in, that's more CapEx, but how would that be recovered in terms of OpEx? We haven't really thought much about that big data piece in terms of demand management, but I think we all need to realise that the OT IT piece is going to play a big role in anything we do, and I'm sure that over time we will do a smarter job than we are doing now of instrumenting all our renewable generation and trying to do the very best we can to operate that really smartly. So I think those are the sorts of things that we're thinking about. And also, how do you match life cycle of the asset with the life cycle of the mine? And I think there's some smart things being done about relocation of assets too, or demountability that we can learn from as well.
Yeah, for sure.
Can I just say something? Matching the assets to the life of mine. Come speak to a Greco. Because we have our rental fleet sitting underneath. So for us, we're very flexible in putting capacity out and taking capacity away. So maybe that's one solution.
Yeah, this is about renewables, mate. So picking up on what you both said, there's adaptation occurring certainly on the producer or the supplier side, but there's also adaptation required on the customer side. Or potential adaptation. Your analogy of the East Pilbara 4 cent a kilowatt hour and running 12 hours a day, what can be done with that? So,
but I think it's important to see that not as, fundamentally my view on this is renewables are an enabler of an outcome rather than an outcome itself, and you just have to accept that as a premise. But the second part is, I've got a handbook of power systems engineering that was given to me the day I graduated, and it was originally printed in 1890. And the basic concept of power system design that is described in that handbook is broadly the same as the concepts that are in the latest edition of whatever power systems handbook we give the graduates in the team have got. The basic concepts haven't changed for 100 years, and so our entire methodology and our entire modality for engaging with energy it doesn't change much, and your job is to make it reliable and use less of it. Now, we have to keep the reliability, but we also actually have to start to think about, well, what does that reliability actually mean, and what are the real definitions of that? But also, how do you change your understanding of how you engage with energy as an enabler of a particular set of outcomes? I think this whole question of reliability is a really interesting one. We hear about renewables being spoken of as being intermittent. And I've heard mining entities say to me, you need to make sure your renewable supply is 100% reliable. And that presupposes that their existing supply is 100% reliable. There are mines in regional Australia who are entirely reliant on diesel, and if there's heavy rain over Christmas, they lose access to their diesel supply chain for 4 weeks at a time and have to shut down their mine. And they will tell you that your solar's not reliable, but diesel's 100% reliable, and clearly that is a circumstance where they lost 4 weeks of production because they couldn't get diesel in there. So there's part of this analysis is actually saying, what does reliability actually mean, and how do you measure that? And you can measure it in mean time between failures, you can mean time to repair, how long are you uptime, all the rest of it. And once you start to put actual hard numbers around it, then that gives the renewable energy industry a target to say, well, okay, we may not be able to get to 100%, but I can get you 6 sigma, I can get you 99.95, or I can get you 4 sigma, whatever that reliability actually is, you can start to target it. But 100% doesn't actually exist. It doesn't exist in any industry. I worked in car manufacturing for a long period of time, and we'd always tell our suppliers, well, you're not allowed to stop our lines because you've got to have 100% uptime. But the reality was we'd stop the line because we blew a limit switch and we'd lose $18,000 a minute because there was a limit switch failed. We didn't get 100% uptime. So understanding what your actual reliability is actually a really critical part of being able to pull apart that value chain.
So we'll move on to the last question, and I'll direct this initially to Daniel. How are technology advances changing the economics of renewables and storage for mines?
Yeah, well, I think this is probably a very a good question for me, because our technology, I guess, is geared for providing a very firm delivery of power. So our technology was its genesis really came out of the aerospace industry. It was designed to capture and store energy so we could provide an equivalent form of energy to a gas or a coal power station, for instance. So, technology exists today that can provide firm electricity at a competitive price. And, we've heard some talk, and I keep picking up reports that quote the price for CSP that sort of date back 10 years ago or more. CSP today can be delivered cost effectively. Our first project in the US was $135 a megawatt hour. As you might have heard one of my colleagues talk about today, we've recently bid projects in Chile at $64 a megawatt hour. So the price is definitely advanced, but the technology exists, and that can provide dispatchable baseload, if you want to call it baseload, or flexible generation, which is a fit for what mining customers generally need.
Anyone else want to chime in here?
Yeah, I guess maybe a few things here. I mean, so this is about the technology and how it's going to change, but Caterpillar originated almost back when that engineering handbook was created, I guess. So we've been around for quite some time. So as a traditional power generation provider, we've been doing electric power since 1939, etc. So adapting our offerings, I think it was about 3 or 4 years ago, had a global dealer principal meeting, and at that meeting, it was we brought in a futurist that came in and said, "This is what's potentially going to happen. You guys need to adjust. You need to move." So as far as adapting and modifying our offerings, we now have CAT solar panels, we now have CAT energy storage, we now have CAT microgrid master controllers that coincide with the generator sets. So really, as we go forward, it's Caterpillar is not going to stand by and go, okay, we're stuck with our generator sets, that's the only way to do it. So the PV array itself, that's going to continue to increase in efficiency. So not only the costs coming down as the efficiency goes up, and the energy yield gets there, you're going to get less and less land required. And then, of course, from an energy storage play, which truly is the key enabler to exploding this. That's an area that we've been investing in, metal air energy storage, which is something that probably not many people have heard about. Ultracapacitors, lithium-ion, of course, are the staples. But as new technologies come online, Caterpillar's really starting to see, of course, that this is absolutely important from us to get in there. And to the point of reliability, we've been in the microgrid space, for nearly 100 years with reliable baseload. We really know that that's the key, that if we introduce something new to the system, we've got to maintain that reliability. So all of these new technologies that come into it really need to be properly designed and engineered before they even get into the actual market space.
Just, I guess another thought that occurred to me as well is, what technology is changing that helps manage lumpy loads, which I know is one of the issues with integration. For example, if you're starting up a mill, that, my understanding, that's usually a very difficult time for a hybrid grid. But are there technologies that are making that something that can be a different sort of softer start that might help with some of the integration issues as well? So I think we're seeing some of that, some things that help renewables manage power factors and power quality and so on. And I think that is increasingly becoming important.
I think also what I notice is in our business we have engineers who come in from different parts of the power market. So grid guys, distribution network, transmission network guys, and it's interesting when you put a problem to a fresh set of eyes, what comes back. And so I think ideas around distributing the solar PV around a mine site, not just having it in one place, so that if a cloud comes over, it doesn't impact all of the PV. Also, trying to ramp down the PV as clouds approach, and there's various interesting sort of low tech ideas that are out there as well. That aid in getting PV built into a mine when you don't have ready access to economic battery storage at the moment. So yeah, it's an interesting space, and it's certainly very much going to change, as we all know.
I was going to say, when I think there's a lot of work to be done around statistics, and sorry to anyone who didn't enjoy statistics at uni, but I think there's, to your point around big data, I think the reality is solar is actually really predictable. It's really predictable at a number of different timescales. The most important one is when a power station operator says to me, well, I have to have X amount of spinning reserve because their cloud might come over, but he's standing in front of a window that he can look out and he can see that there is no cloud coming. And if there's no cloud on the horizon, and for any of the remote power stations in remote arid parts of Australia, if there's no cloud on the horizon, you're right for the next hour. In fact, you're probably right for the next 2 hours. If there is cloud there, then you can start to ramp down and you can start to make some assumptions around that. There's statistical work that's been done around the appropriate levels of the dispersion to get plants moved away from each other so that you can get a smoothing effect. We ran a study in Alice Springs where we put in a series of pyronometers around Alice Springs in concentric circles. We built up a transform model of what a single point pyronometer actually does, and everyone will see graphs of showing solar radiation doing this when you look at a single pyronometer, but when you spread it out over 1 megawatt or 3 megawatts or 10 megawatts, there's a smoothing effect that comes from it. But when we actually looked at that across a range of plants, and then we measured that against the actual the variability on the load on the existing power station Alice Springs, we were actually able to demonstrate that at certain times of the year, the diversity was such that we removed, when you looked at the statistics, those of you who remember your standard deviation, your variance calculations, we could actually lower the aggregate variance in the system in the middle of the day compared to what the power system was already dealing with overnight from switching on of air conditioners and loads and other bits and pieces. So when you start to, over-design, you have a bit of extra capacity in those systems so you can ramp up and ramp down. You start to look at it as a system rather than as individual plants, and you start to think creatively around how you actually manage the asset rather than looking at aggregate levels, absolute levels of my absolute percentage should never get above 50%, and start thinking about rates of change and a risk-based approach that says in certain times of the year I'm absolutely happy to get 50% or 80% because there's no cloud cover and I run at that level. But then you can start to ramp down at other areas.
I think one other point that I'd make is so the discussion's been very sort of focused on these arid areas, like you talk about West Australia and the Northern Territory. Once you move into the tropics, the density of your cloud and also your layering of the cloud leads to different cloud characteristics and different behaviours when it comes to your PV output and your ability to sort of roughly predict what's sort of happening. So
it's still predictable.
Well, the problem that you face as a generator is if you don't get it right and it trips and it's an underground mine, and it takes 4 hours or like 12 hours, and you're on the hook for $50,000 or $100,000 an hour in liquidated damages. Your engineers start to get really nervous, and when the engineers get nervous, they throw more equipment at a solution, and more equipment equals more capex, and more capex means that you don't win the tender. So, it's not a trivial problem, but it's something which there's a lot of work being done on it, and things will get sorted out over time. Like as we're seeing, so Greco now is prepared to take the risk on 7.5 megs of generation on a 20 megawatt diesel station. So, things are changing, but I think we don't want to oversimplify, the problem of keeping the power on, and also the penalties that people have to pay when the power comes off, even where it's a trip. So if in some contracts where your power station might go off, and then you can restart it like a minute later, but the miner can't operate for 4 hours or 12 hours, you still get hit with those liquidated damages, or you can do if you don't negotiate the contract for the time that the mine's not operating. So there's a lot of money a miner can lose when the power goes off, even for an instant.
I think I wasn't trying to trivialise the significance of those issues, but the important bit to understand is that they are quantifiable, and we spend a lot of time talking about renewable fractions and whether it's percentage of energy or percentage of power, and what those numbers are interesting, but actually what matters is dealing with the system as a dynamic system. And there's certain times of day that those risks are higher, and I think the renewables industry actually has to start providing the data sets to actually show what's actually going on. There is a paucity of data around describing the scope of these risks. And we've got data sets out of places like Groote Eylandt, and we can show that over a large number of years, if you, in June, dry season, if you have zero cloud at 9 o'clock in the morning, you've got a 6 sigma level of certainty that there'll be no cloud for the balance of the day. If you get, in February, in the peak of the wet season, if you've got no cloud at 9 o'clock, you've got a 3 sigma certainty there'll be no cloud at midday. And so you can start to... Now, I
like your thinking there, but as a former power trader, when correlations come apart, they tend to be spring-loaded. So where you're and also the other thing is forecasts, you can guarantee to be wrong always. But I think, where you do get it wrong and you have the potential for a big sort of liquidated damages claim, things start to get, quite interesting. But in saying that, maybe some of the risk can be shared across both parties, and you can sort of say, look, the statistics say that there's a very low chance that we're going to see cloud today, which is going to trip up the power station. But if it does happen, how about we both sort of share the risk on that? Maybe there's things, because a PPA is a fully negotiated, contract. Everything's negotiable. It's like an OTC, derivative. So, you can put in there whatever you want. So maybe that's something you do.
And I think that's the challenge for the renewable developers, is to start to see that this risk, this is actually not about absolute sets of values. It is actually about a risk reward, and there's certain things that you can predict and there's certain things you can't predict, and it's working out where the value chain in that, where the value opportunities are in that chain is actually a really important part. And that is then started to be driven by new approaches to the data sets and the design.
And I think the paucity of data is a really important point. Like there is a lack of data for us to pore over to see how these behaviours play out.
Thanks, guys. Rich discussion. I think it's time we open it up to the floor for questions. Any questions out there? There's one over here.
Hello, Jeff Roper from Ingot Team. It might not be as crazy as the nuclear option, but your comment about running a 50 meg plant with 150 meg solar and the discussions around exporting hydrogen, would it not be so crazy to be producing hydrogen at the same time for export, also being able to store it for an extended period of time where you can burn hydrogen overnight to run the plant? And when the plant's closed, you can then just produce hydrogen?
Who wants to tackle that one?
I'm game. I think all of those options are available. I think there's the point that I was trying to make is that when you start to conceive of a world where the access to energy is suddenly lower, that the price of the energy is very low, but it does have constraints around time and reliability that you need to deal with. It does afford you the opportunity to rethink what your value stream is within the context of the use of that energy. And so it could be use of hydrogen and production of hydrogen. There's many people who are doing work on that, and I think Paul Ebert mentioned earlier that some of the more recent reports are probably more positive than some of us felt previously. But it's also what other embedded energy or what other areas of the value chain can you embed energy into? There's queries around how that work looks in transport. There's work that we're engaged in Northern Territory and looking around transport routes that have been traditionally dominated by diesel, and what are the opportunities for battery and battery electric and fuel cells. There's a lot of opportunities that start to come out, but it requires you to jump forward to say, if we had effectively very low cost energy, what would you do? And that's not normally a conversation we have, because most of the newspapers are dominated by how high the cost of energy is, and there's a dichotomy emerging about where the actual underlying trend of wholesale energy is at, or bulk production is, versus what the cost of our energy system is.
I guess I'd just make a comment, thinking from the point of view of a customer. If we bring this back to renewables providing solutions to mining customers, energy is not worth fundamentally more to a customer because it's been through a battery. It might be worth more if they can't get it at that time unless it goes through a battery, but the current models don't have that. Maybe that's coming. But so we've just got to think about it in terms of how do we get a commercially attractive offer to the customer, and if the technologies are going to come down in cost, then how do we pay for that to commercialise them so we can get a commercially attractive offer. And I think once we're in that ballpark, then all of these solutions become things that are options for us.
Thanks, Jenny. Questions anymore? There's one over here.
Hi, I'm Travis Inman from Rio Tinto. I'm Environment Manager there. My question is in relation to the fact that the majority of our energy usage is in mobile fleet, and I guess particularly from the guys from CAT, while diesel is, the right fuel right here, right now, I was just interested in any insights on what the blue sky thinking is on alternative fuels or technology for our mobile fleet.
That's a question that I might not be able to completely answer for. I'm more in the power system side than the transport side. But definitely, I'm aware of certainly the gas-powered trucks and transport facilities. Of course, there's hybridisation of that, which Caterpillar also has, but that's not necessarily replacing. That's making the fuel you've got more efficient, etc. Whether that goes down to an electric trolley system, which I'm not sure if you've got that on your site, and then you can then power that electric system from a renewable power source directly. But I might need to defer that more to my machines colleagues and get back to you.
Yeah, no worries. The only other thing we've thought of is with autonomous trucks, maybe hydrogen's a bit more palatable than otherwise. But I think the challenge though for the mining industry is trying to unlock that.
Yeah.
Because while we're all for the renewable energy piece with electricity, almost that problem's solved now. But to unlock the green mine of the future that we were talking about earlier, mobile equipment needs to be either on the agenda or we start mining differently. Yeah. Thanks.
More questions? Okay, I think we're going to wrap it up. Please join me in thanking our panellists.